Professor Gavoor. In the online book, we're going to cover manufacturing and service operations, which is Learning Block 5. In this block, we'll talk about the supply chain elements of manufacturing and service. And they call it M&SO. I don't really call it that. And it's accountable for the management resources, processes that provide the saleable products and goods. So when I say the right products in the right place in the right time, that's what we're talking about. The right services in the right place with the right capacity to deliver them in the right time. That's what I'm talking about. Manufacturing operations apply all the resources, which include labor, materials, and equipment, and often to produce a tangible item that can be placed in inventory, and the inventory can be a store shelf or it can be in your own warehouse or an Amazon warehouse, which is in between your manufacturing warehouse and a store. Service, on the other hand, applies labor, tools, and equipment, including oftentimes spare parts and materials that they need to provide the service. And so it cannot be placed in inventory. It has to be kind of delivered as needed, but depending on the kind of service industry. If you paint houses, and if that's your service, you can't inventory that. If you provide spare parts and repairs, you can inventory parts of that. So manufacturing and service operations is an important link in a supply chain. It's kind of like the heart of it. Most people that look at operations consider themselves manufacturing people for the most part. Of course, that's changed over time a little bit. But in the companies I've worked for, the people that seem to get ahead in operations are people that have actually worked in and they ran plants and then expanded their capability to logistics, transport, the logistics aspects, the planning aspects, and all the other parts of all the learning modules that we're covering. The heart of it is this. So this is the objectives. I don't cover the objectives often, so I'll let you read that as you wish. So, and we talked about it already. Manufacturing operations apply labor, materials, and equipment to produce the goods. The goal is to have the right goods in the right place at the right time in the right quantities in order to support the sales, which drives the revenue of the company. In service, it's the same thing. We are applying labor, tools, equipment, sometimes parts, spare parts, whatever the case may be, to be able to provide the right service in the right quantities at the right time. It's just can't be inventoried like manufactured goods can be. That would be the difference. But the planning, a lot of the planning is still the same. Right now in this COVID environment, service is my local grocery store. I mean, they have inventory on the shelves. I could go there and buy it myself, or I could use a curbside pickup where I order the products online and then go and pick it up. The problem I had recently was I finally downloaded the app and decided to try it out. So I went through and did all my shopping and had like $50 approximately worth of goods. And then I went to checkout. And in checking out, you have to schedule, a 1 hour, 2 hour delivery time. So I looked at the next day, nothing available, not available, not available, not available, and all of it was not available. So I called the store. I said, "Is there a software issue, or are you really having that much demand?" They said, "Oh, the demand's crazy." They had 80 such orders a day. It's just not a big grocery store. And so therefore they only have a small number of people allocated to doing this job. I imagine that will change moving forward, and they will dedicate all their staff to that, run around the store and pick it up. But right now their mix is probably they can take anybody that comes into the store, and the store is always crowded, but they can only handle about 80 a day. So they are not able to provide that service. And they can't inventory that. They can only assign more people to it. So oftentimes when we look at manufacturing and service operations, operations converts materials into products. And oftentimes in a lecture like this on manufacturing and service operations, it mostly becomes a manufacturing discussion. So I'll try to bring in whenever you can do it. But if you look at this, and there's always flow charts that you want to look at. So if we look at this schematic, you can see how a sales plan is important here, product development is important, and then the whole order management process is important. So it's the conversion of this part. You have a supplier, you have material production, procurement, and then you have production instructions, production and testing, shipment to customer. That's the core part. There's a lot of parts that support this. So sales plan and demand forecast are critical. They drive the purchase of raw materials. As we said in that module, you cannot have the right products in the right place at the right time in the right quantities if your forecast has the wrong products in the wrong quantities at the wrong times. So you've got to match that up as best you can. Manufacturing is very process driven. And here's a simple process diagram. You have some inputs. You transform those inputs, which are energy. It could be your raw and packed materials. It could be your semi-finished goods. It could be nuts and bolts and like fastener kinds of things. And you have labor is also an input. You combine all those together and transform those raw and packed materials mostly and your semi-finished goods into something that has higher value than the value of all the inputs into an output that customers hopefully want to buy. You want to have controls over all this so that you can produce it efficiently and effectively and according to your planning. So a process by definition is a set of activities to accomplish something. You have a process for doing your homework. I have a process for making these lectures. Manufacturing processes are unique because you can actually see the process. You can stand on the mezzanine of the factory and see the machines that will be making whatever it is you make. If I'm making a pen, I can see the machines that are making injection molding the bodies of the very cheap like Papermate pens. I can see where they're making the refills. I can see where they're injection molding all the plastic parts, not only the body, but the cap, the little end piece, all that stuff. And then I can see where I can't see where they're making the ink because they make that in a different facility. And the balls are purchased from a different facility. But I can see where they assemble the refill, I can see where they do all injection molding, and then I can see where they assemble the final pen and package it. You can just see it. You can go up and kick the machines. If you want to see how I make these videos, I can draw a picture of it, but you can't see it, really. I mean, you could witness me doing it. You could understand how I explain it to you, but there's not physical machines that I can walk up and kick except my computer, and if you kick it, I'll be out of business because it won't work anymore. That's me trying to be funny there. Okay, manufacturing routing. One of the things that we want to do, manufacturing is what is the process in manufacturing? How are things routed? Now, oftentimes you would like to think it's very linear, but depending on the factory, how it's organized, you may have injection molding all in one area, and then you put things in boxes and move them to the assembly area. That's how they're routed. Or you may have it integrated, where the injection molding quickly gets turned into a finished pen and it's all in line. It really depends on the nature of the business and how you want to do it. So they're talking about 4 items. An overall process plan to make an item is referred to as manufacturing routing. It's based on a collection of the individual processes, inputs, ingredients to make raw cookie dough, and packaging supplies. Output, baked cookies that would be packed, packaged, and transport to retailers. Controls, the recipe, the oven temperature, the baking direction. So it's basically what is your feeds and speeds, if you would, to your process, and then how you're going to actually control them. And the resources are the ovens, the labor to make the cookies, and the energy required to run the ovens. I imagine it's probably very expensive. Here's a breakfast process example. Okay, make breakfast. Inputs are eggs, milk, bread, butter, bacon, plates, utensils, cookware, potatoes. I don't know why potatoes got stuck there at the end, but that's okay. You make breakfast, and the output is scrambled eggs, toast, crisp bacon, pan-fried potatoes on a plate with utensils ready to eat. They forgot a napkin. I always forget napkins. You shouldn't. All right, so make breakfast. Prepare the ingredients. Cook ingredients. Serve the ingredients. Now, cook ingredients are cooked bacon, cooked eggs, toast bread, fried potatoes. They've got it in order. Do I do this simultaneously, or is it really a flow like this? I don't think it's really a flow like that. But if I look at cook eggs, heat pan, pour mixture, stir mixture, add pepper, remove eggs. It might be break eggs, put in bowls. It depends on the detail of what you're trying to do. Nowhere in here in this COVID world did it say wash your hands several times. Probably that's something we have to add to this process and make very clear. All right, so here's a coffee process exercise. Click on YouTube, watch it. I would say with 2-3 partners, diagram the coffee production process. Just look at it yourself and get a feel for how coffee is made. All right, so we'll not only look at it, but we'll talk to you. You collect collection of green coffee. So, every process has a start and a finish. If you didn't have this, it would be, tilling the field, buying the coffee seeds, coffee beans as seeds, planting the coffee beans, nurturing the growth of the plants. It takes X amount of time before a coffee plant starts, or plant starts yielding fruit, which would be, I think, the coffee berries, I believe they call it, and which you collect, and then you can get the green coffee beans from that. But in this process, we're assuming that you're a factory that is getting that supply from someplace else. And notice that you store them in some sort of bin storage place. So then you have a roasting grinding process. Probably in between you have a cleaning process. They didn't talk about that, but probably it's implied that the cleaning process is in a roasting grinding. You don't want to roast and grind dirt, sand, twigs, mice feces, feces from animals that might have gotten in there. The animals themselves, insects, whatever, you want to clean all that stuff off. Then you roast it and grind it. How do you do that? That could be a process more detailed than this in itself. Extraction. I'm not sure what that process is. I have to watch the video myself. You could have a concentration of the product, and then the freezing, the granulation. So they're making freeze-dried packaged coffee, which is probably not as popular as it used to be. But you can watch a YouTube video on this as well. The product process matrix. Well, it links the marketing decisions and the product's life cycle to an organization's capabilities. If you have to produce something that you can't manufacture due to the equipment you have. So if the marketing and product development people design a product that's outside, beyond the capability of your current machinery to produce at the specifications they want, and we're talking about tolerances, how tight the fits have to be, how precise the cooking has to be, how precise the measurement of ingredients has to be. If it's beyond your current capability, you may have to invest in new machinery to do that. That could be very costly. So if we look at this, we're looking at it from the kind of process, they're looking at it right now in the kind of process you have. So let's stick with that part. A project process is a high variety and low volume, custom homes or bridges. I always like to use defense examples. Nuclear submarines, aircraft carriers. Probably each one has a different variety and they're putting different bells and whistles on each one they build, so they're custom made. You don't keep them in inventory. A job process is a medium to low volume and with a medium to high variety. So if you're thinking about from a service standpoint, it would be a beauty shop where everybody comes in and wants something just a little different, a little tint, a little different color, a little this, a little different curl, tighter on the side, longer on the top, blah, blah, blah. Auto repair shops, you never know what's coming in for the job that you have to do. Also, I used to do some consulting for a company that did transmissions for NASCAR. You would think that it's pretty easy, but depending on the track, the driver, and how they did in the last race and the last time they raced at that particular track, they're always changing the gearing and building up transmissions specifically for a specific race and wanting to have a couple of them, one to test out, and if it breaks, have another one that they can put in before the race starts. So it's produced to order. The project process is produced to order. The batch process, however, is you don't carry much inventory. Especially in a project process, you only have the inventory that you're going to use for that aircraft carrier, that nuclear submarine, or that Airbus airplane. The job shop process, you may carry a lot of gears and decide which ones to use to assemble the specific transmission that you're putting together for driver XYZ for race ABC. A batch process is medium volume and medium variety, and we're talking about bakeries and production of auto parts there. The repetitive process is medium to high, and it's medium to low in variety. It's basically all of your consumer goods. In a manufacturing sense, you're building to stock, and we'll talk about that later. So as opposed to build to order, build to stock, or build to inventory. And a continuous process is a high volume and low variety. Oil refineries, chemical. You can even produce bar soap in a continuous process these days, where you're just constantly feeding in the raw crude oil and refining it on an ongoing basis. So there's a product life cycle too. You introduce a product, it's like you start brand new, and the product is launched, and of course every product that's launched is destined to be the next iPhone, at least by the people that developed it. They want it to be an unbelievable success. Most of them are not, but in introduction phase, you're learning how to produce it, and sales grow slowly, thankfully, as you do it, and the product starts to grow. Your manufacturing grows with it, and next thing you know, you're getting very efficient at it. So think of LED light bulbs. When they were introduced, they produced very little. The sales weren't robust, and the light bulbs cost a lot of money because the factories were expensive, the fixed costs were high. That fixed cost was absorbed by a small number of output of the factory. As the factory grew and the market grew, right now LED light bulbs have basically taken over the market, and they have at the prices that the incandescent light bulbs used to be at. So we have that, and they've taken a lot of cost out of it, and it's getting there. I don't know when LED light bulbs will mature. It looks like I think they will have a long run, but they could. And then you'll have a decline where you fail. I mean, if you look at the incandescent light bulbs, they matured probably in the 60s, 70s, 80s, and they've constantly been trying to take cost out of it, but at that maturity process, they're certainly in a decline right now. So probably the prices will go up before they're completely taken out of the market, because the manufacturing capacity will be going down. So we talked about this, the introduction, the growth, the maturity, and the decline. You can read about it further on this slide. Here's another graphic of the same. It's time and sales. If we talk about trendy products, they can cut the time involved can be very, very short. Like if you have the toy of the year, Beanie Babies, which was popular way back when. I mean, you couldn't, they were on the shelves and flying off the shelves so fast. But it was only like for about a year. And they matured. I mean, you could still buy them, but not in the volumes that they were when it was really popular. Something like Oreos has been around for a long time, and we're in a very, very long mature process there. So the supply chain, the manufacturing arm of the company, has to support the lifestyle, so processes within the supply chain may change over time. When do you expand a factory? When do you pull back on capacity you allocate to one product and give that capacity to another product? So when we talk about manufacturing and service operations, and as more people work for service, the economy has become more service oriented than product manufacturing companies. A lot of that has to do with exporting manufacturing out, but also a large section of that has to do with the efficiency with which we run factories these days. In the days when I first went into factories that did plastic parts, injection molding machines, you could look up what an injection molding machine is and does. But basically, it makes pen bodies and pen caps. It makes any of the kind of products that you look at that are made of plastic and kind of assembled. So bottles are blow molded, not injection molded. So it's not bottles, but it's almost all the other plastic parts you have. When I first walked into a factory, they used to have one person tending a machine. So you'd have an injection molding machine and one person kind of operating it. Now if you walk in a factory, most of these machines are more highly automated, and you might have only one person operating 6 machines, tending after them and looking after them, making sure they're still working. And if there's any on the computer consoles that are used to run it, if there's any concerns or issues that come up that require human intervention, they've got to follow it and do that. So a large part of, even if manufacturing comes back to this country, which people are hoping and working towards, the jobs won't come back with them in the same degrees that the jobs left manufacturing. Okay, so difference between manufacturing and service. Output of manufacturing, like we said, can be put in inventory. It's hard to inventory service because service is based on capacity. You could provide more service by having more capacity. The example I used of my local grocery store and their ability to do process electronic orders for curbside pickup, they have to reallocate how they use their labor force in order to increase that capacity. I would imagine within the next 2 weeks they'll probably get that figured out, maybe even hire some more people. So while lots of industries are furloughing workers, grocery stores, Amazon is hiring. They're hired 100,000 workers just last week, looking to hire 100,000 workers. So they're not always separate, and in fact can work together. So there's a manufacturing and a service component to most manufactured goods. If you produce the entire idea of having an 800 number for product that you buy, and a website to provide support. If you have any questions, you're new, blah, 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 and you're not quite sure how to do this, that, the other thing. If you need help, call us, we'll help you. So there's always a service aspect that's involved in manufactured products, and we've already had exercise where we talk about that continuum. What's pure service, what's pure manufacturing, and there's a lot of gray in between that. So when we look at inputs, manufacturing inputs include labor, raw materials, components, resources, which are your utilities of electricity, water, etc. Technology, which is the technology of the machinery, but also the IT technology that helps one person basically run 6 injection molding machines. Service inputs include products, like if I'm going to install If I'm an electrician and I'm providing a service, I have to have all the circuit boxes and breakers and wire and whatever I need to do my job. I have to have the people to actually go to people's homes and factories and businesses and do the actual work. And then I have a variety of technology. I could have voltage meters, a variety of things. Even when I order a product from Apt, their cell phones are tethered to the home office, and they can invoice me right on the spot, and it's emailed to me, and it's a lot of technology involved there. So if we look at these graphs, manufacturing jobs stagnate, service jobs boom. So manufacturing jobs stagnate. Even is that true? Millions of jobs, and this is into the mid 2010s. We're at the beginning of the 2020s now. You would think, okay, well, manufacturing is stable. Well, I think manufacturing has probably actually increased to a certain degree here, but the number of jobs have stayed the same. Even with the jobs leaving, manufacturing has probably increased here. We're still a large manufacturing country. We just don't have the jobs there anymore because they've been automated away. A lot of service jobs, you need people to do it. If you're going to go to that service economy where you're going to order everything online and have it delivered to you, you need an army of people to deliver that stuff to you and pick that stuff in the warehouse. You're no longer doing the shopping in a warehouse, in a grocery store. Someone's doing the shopping for you. They're selecting your items and putting them in your basket at the Amazon warehouse. And then someone else is delivering it to your house. You used to do that yourself. They had an army of people that would get things efficiently to within a mile of your house. But now the whole nature of retail is transforming. So if we look at this, the key measures, the key process within operation. So we're talking about what? Production of tangible goods. And we're talking about cars, engines, steel, computer, screens, memory, plastics, shovels, clothes, anything you could think of that is a tangible product. Services, the ones that really can't be put in inventory, you're talking about government, you're talking about retail stores, you're talking about financial services, you're talking about dry cleaners, you're talking about schools, you're talking about tax preparation, you're talking about home repair of every kind. And the list for both of these goes on forever. So when we talk about service and manufacturing together, we're talking, you have a manufacturing operation of a car. Well, the service aspect is when you go to the showroom and someone teaches you how to operate everything in a car, and of course then your grandparents forget how to operate the GPS and you've got to teach them again. But then they provide an extended warranty, or they provide a warranty for a base pallet, but you might buy an added warranty or an added service contract, in which service contract, it's service. So when you bring your car in for maintenance, this, that, and the other thing, you have that ongoing experience. So there's two things. You manufacture the car, and a lot of times consumers will look at that and say, oh, I love the car, I love the design, I get it, brand new, wow, it's really great, it's really cushy. But then they judge the company as much on the showroom experience and the service experience. And if you make the consumer happier over time, with one, you design and build a car that's very reliable and doesn't need that much service. But then when you provide the service, people feel well tended to and well catered to. Well, that's pretty good. They will come back to you. That breeds owner loyalty and customer loyalty. So that's what you want to try to drive at. So let's talk about this now. We talked about demand a little bit before. We said, how many cars do we have to build? How many pens do we have to make? How many blah, blah, blah do we expect to sell? Well, that's good. We have something, that's the independent demand. That's the output of the company that what we're going to sell. So in the automotive example, demand is the number of cars sold. How many cars do we think we're going to sell in April? Well, I'll tell you what, right now Ford and GM are probably scurrying like crazy because they're not going to sell nearly as many cars as they thought they were going to sell in April when they were looking at this back in December and November, which is probably when they were planning it well in advance, but the number of cars is going to be drastically reduced. So each car depends on all the component parts. It has 4 wheels, 4 tires, 4 sets of brakes. It has 1 steering wheel, 1 entertainment unit, radio slash, I guess I don't even know what we call it now because it's 1 console that does everything. Kind of the computer on the car. How many hoses, how many tubes, how many spark plugs, how many engines. Only 1 engine, but each engine in turn may have 4, 6, or 8 spark plugs. We keep track of all these with something called the bill of materials. It's basically a recipe for making the car. A recipe for making a cake is 2 eggs, 4 cups of flour, some leavening agent like baking soda or baking powder, vanilla extract, probably a wee bit of salt. What else goes in there? Almond extract, whatever it is, you add flavor to the cake, artificial coloring, flavor that makes a chocolate cake look chocolate. Maybe they actually use chocolate or lemon flavor, whatever the case it may be. You have a recipe for cake. Well, you have a recipe for a car too. I need 4 wheels for this, that, the other thing. But when it comes to an automobile, you've got to specify exactly which part you're talking about. 4 tires. Well, we have tires of all different sizes. Which size tire do you mean? Which manufacturer of tire? Et cetera, et cetera. What spark plugs are we using? Which steering wheel are we using? Which blah, 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 blah. If you could use 1 steering wheel over all your cars, you're saving lots of money. If you have to have a separate steering wheel set up for every car that you make, it's a little bit more complicated. You could have a luxury steering wheel versus a more proletariat steering wheel, clad in leather versus just a plastic one or a vinyl one. On and on. There's no end. Plus, these things are always being revised, so you have to have the engineering revision. So I could have a product for, let's say, steering wheel 1, 2, 3, 4 that goes into this car, but it could be 1, 2, 3, 4 point 1, point 2, point 3, which would be represented engineering revision, or oftentimes that's represented by a date. So as you realize that, this product, the millions of parts that go into a car, this one is causing us a little bit of issue. Let's fix it. Oh yeah, we redesigned it. We'll change the dimensions. A little wee bit. We'll change the materials that go into it, perhaps to make it more robust. And therefore, you have an engineering revision. So you got to keep track of that. Here's a simple one. You're building a cabinet. Here's all the parts. You've got hardware, screws, fasteners they call them, the doors, the shell, so the frame, the doors, and the common parts that go to everything. And that would be your planning bill of materials. Now, if you keep changing that, you've got to change that as well by engineering revision. So let's look at a simple one. You have a table. It has 4 legs, 2 ends, 2 sides, and a hardware kit. I guess it has a top too, but they didn't include that for some reason. 1 top and 1 hardware kit. So if you're buying something from IKEA, that's the bill of materials for what goes in the package. Also, the packaging would have to be part of the bill of materials. The cardboard, the strapping, the staples. And the hardware kit, you have your own bill of materials for what goes in there. 4 screws of this type, 4 screws of that type, washers, this, that, the other thing, and even a little tool so that people that don't have a toolbox at home can assemble your stuff. So for a car, it's really complicated. For something as simple as a table, it might be less complicated. And then when you're looking at this demand exercise, what's the dependent demand? So in January, we're going to make 2 tables. In February, we're going to make 10. And maybe instead of 2, it's 2,000. 10,000, 8,000, 6,000, 12,000, 16,000. Then I'll need 4 times that in legs, 2 times that in ends, 2 times that in sides, and 1 for 1 for kit. So the multiplier for the kit is only 1. I need 1 kit for each table that I'm going to make. So maybe they have 8 bolts, 8 nuts. You can see how they've expanded. The first level of the bill of materials is this. The second level of bill of materials is what goes into the kit. So you're exploding the BOM, which they call bomb, to the next level. This is level 3. Even the sides. What goes into making the sides? If you're going to make the sides yourself, you need to specify the kind of wood you're going to have, the kind of finish you're going to put on it. So if you explode the bomb all across the board, you can have it. The legs, wood, finish, and the finish could be different than the sides because you've seen two-tone tables. And the bottoms of the legs, you might have a wooden leg, but you put a little cap on it so that it sits on the floor, that piece of plastic or metal that is between the actual wood leg and the floor. So you can explode this bill of materials down. And every level you go down, it gets more and more dramatic, more and more detailed. Imagine a car. It would be crazy when you think about the amount of materials that go into a car. So defining how products are made or sold, engineered to order. When we talk about the project process, like the nuclear submarine or the aircraft carrier, they're engineered to order. Not only do you not make them till you order them, you actually have a base engineering drawing and a bill of materials for the base product, but then you engineer it for each specific application of even if it's your only customer is the U.S. Navy, every aircraft carrier is not exactly the same. They may change the powertrain. They may change this, that, the other thing. They may change the weapon control. They may change the launch thing for airplanes off a carrier, etc. So you engineer it to order, and then you make it to order. So engineered to order means highly customized. You might build 2 very similar skyscrapers. If you go the Peachtree Center in Atlanta, I forgot what the name of the center was in Los Angeles, and the Renaissance Center in Detroit, they're basically the same building. When you look at them, you say, oh, I saw this, like almost the same as a building in Atlanta and LA when you're in Detroit. I think Detroit was first, the other 2 came after, but they're not the same. They might have changed the elevators, they might have changed the kind of concrete they use based on the seismic activity in LA versus the other 2 locations. They might change the nature of the glass depending on the temperature profile and the amount of reflectivity they want. They might have changed, everything. So everything is engineered to order and then built very custom. Make to order allows some customization, but components may be inventoried. Like if you have t-shirts or condos. Condos have less customization than an entire office building complex or a nuclear submarine or aircraft carrier. Condos are like you have set options that you can look at. Cars, sometimes, they used to be make to order. People always used to order their cars. I want this color, I want that, blah, 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 and they tell you what day your car is going to be made. But assemble to order is even quicker. Most of the time when you order a custom computer from Apple, you can buy Apple computers off the shelf, but if you want them to make something for you and you want this size hard drive and this size screen and that kind of screen and this kind of graphic card and that kind of interface, sound interface card, I forgot what they're called. They'll put all that together and they're taking it out of inventory and producing your computer for you. At the same time, they're also producing a set of stock laptops and desktops that go to the various department stores and websites where you can buy this stuff in a stock setting. And that brings us to what we call make to stock. I can't, here's the example I use. I go to the grocery store and I buy a box of Cheerios. Um, the grocery store doesn't let General Mills know, hey, we sold a box of Cheerios, a 1 pound box of regular Cheerios. Can you make us another and ship it to us so we can replenish our stock? It doesn't work that way. General Mills decides and prognosticates how many Cheerios they think they're going to sell in the next month. And believe me, they're working frantically to figure out if that's going up or down right now in this COVID thing. And then they decide what they're going to produce. They produce it and they hold it in stock, and then they deliver it to warehouses of their customers being the Amazons of the world, to the Jewels and Mariano's and Kroger's of the world, who then stock their stores with it or send it directly to consumers, depending on if it's Amazon or a traditional brick and mortar grocery store. So that's called make to stock. I produce goods in anticipation of demand. Assemble to order, I can do that quicker. I get an order and I have all the parts, I just have to assemble it. The NASCAR company I talked about was in between make to order and assemble to order when they would make the transmissions for NASCAR. Because you could configure it with, I want this size transfer case, I want these gears and these number of gears and this kind of shaft inside the transmission, and then you would build it for them. Make to order is assemble to order and make to order. There's no work done except the prep work and keeping the inventory until the order actually comes in. Then they will work, schedule, and produce your order for you. Engineer to order, they don't do anything really. They have some work that they do on designing a class of product, like a class of office tower, a class of aircraft carrier or nuclear submarine or whatever the case may be. But they don't, when they get an order and a signed purchase order, then they will re-engineer and specify, to your specific needs. And then when that's agreed to, then finally start building your product. Now, if the hull of an aircraft carrier is fixed and you're not going to really change the dimensions of that, you could start building the hull and getting that going while you're re-engineering or engineering the parts that are variable, so you could save time in the overall process. So the production strategy has to align with the customer expectation. That's absolutely true. So if you talk about the lead time on one and the volume, long lead times, low volumes, engineer to order. And as the volume starts to pick up and the lead time drops, and probably the cost of the item also could drop. But when you get to make to order, less lead time, higher volume. You get to assemble to order, less lead time, higher volume. And when you get to make to stock, you're talking about high volume consumer packaged goods. And it's very high volume, very short lead times. So defining how services are offered. Service factory, low labor costs, low customization, low customer interaction. Trucking companies, airlines. They're price driven and they focus on facility and equipment utilization, maximizing output and keeping costs low. A service shop, high customization, customer interaction, but relatively low labor costs, like auto repair shops would be here. You never know what you're going to do, but everything that comes in is different. This car needs a new transmission. This car needs just basic oil change. This car needs a brake job. This car needs a new water heater or water pump, And they want to focus on efficient scheduling and technology. Oftentimes in an auto repair shop, you have the diagnosis part too, which I think they've gotten much better at because all cars can, basically plug into a diagnostic computer that interfaces with the computer on your car that you probably don't even know you have. Mass service, low customization and customer interaction, but labor costs are relatively high. So retail banks focus on improving service times, Oftentimes through automation, what have banks gone to? ATMs. ATMs are not cheap, but over time they're less expensive than people because you could pay for the once you pay off the ATM, it's just a workhorse for you. And then professional service, high customization and customer interaction, high labor costs. We're talking about doctors, lawyers. It's a highly educated workforce, and services are time consuming, deeply customized, and can often have an expensive cost component like medical tests and whatnot. So let's move into quality. It's critical in both service and manufacturing. Companies can lose market share very quickly if their products or services are viewed in an ill way by their customers and consumers. So you have to spend a lot of time making sure that your quality is proper and that you build quality into both the service and the product, because customers, even if you have good service, oh, something went wrong, yeah, we'll get you a new one right away. It just irritates people. People are not used to this day and age of having things break very, very easily or very often. I have a little bit of problem with this one. The Malcolm Baldrige Quality Award is a national quality award, and it's a standard that companies can use to improve themselves. That part's all true. Emphasizing it in a class like this, I don't think many industries pay any attention to it anymore. I think it was a reaction to Japan's Deming Prize, which Japan used quite effectively in the 60s, 70s, and 80s to move their industries to a higher level of quality, in almost every case surpassing their international competitors. And even that award in Japan has a lesser impact than it did back then. So I think focusing on this is not as important as it used to be. Six Sigma, however, was really popular until really recently, and I think companies still use it. It's not as hot as it was, but Six Sigma is a quality improvement, process improvement methodology. All these methodologies are based on the scientific method. Yeah, that scientific method that you learned in fifth grade. Make a hypothesis, collect some data. Does the data support the hypothesis? If so, you have a predictive model moving forward. If not, go to step one, revise your hypothesis, collect some more data, and keep doing it until you have an answer. Well, the hypothesis in this case is, why are we having quality failures? I think this is the reason. Okay, let's collect some data. Was it correct? Okay, good. What is our remedial action we can take to mitigate this from ever happening again? Let's implement it. Let's verify that it happened. If that didn't work, go back and hypothesize what might be the root cause of the quality problem and just keep reiterating. Now, because there's so many consultants in the world of quality and productivity, there's four-step methods, 5, 6, 7, 8. If I'm a consultant, I'm going to say, hey, listen, I have my unique Gavoor 8-step method, and I have to make it look different and better than other people's, or else you're not going to buy my services at a premium. Six Sigma is something that really, really caught on. It's one of those methods that started at Motorola, and the importance was that management picked the projects and prioritized the projects they wanted working teams to address. And it had a lot of power at the beginning, but then, like anything else, it became a bureaucracy, and the shine is off the apple a little bit right now. So here's the Malcolm Baldrige National Quality Award. This has been replaced by ISO quality standards, pretty much. And that's what people use. So it's presented annually to manufacturing, service, small business, education, healthcare, and nonprofit. I think it's still viewed pretty strongly in healthcare and education, perhaps even nonprofit. I think the manufacturing and service companies aren't using it as much. And they're the ones that are using more of the ISO standards, or quality standards and certifications. So this is done by the National Institute of Standards and Technology. And, it has to do with plan, implementing, measure, and review. So What is your leadership plan? What is your strategic planning in terms of quality? What are your manufacturing and management and HR focus in terms of that? How are you going to implement it? What is the measurement, analysis, and knowledge management things that you're going to do to implement your quality plan? And then, did you get results? Did you have the business and performance results that you did all this leadership planning and strategic planning to achieve? If you didn't do it, it's not successful. And did you maintain a customer focus? Because if you don't do it for the customer, you won't get the business results. If you can design a beautiful product that customers don't want, if you do that, you'll have a beautiful product that doesn't sell. So you want to focus on the customers. So that's basically how the quality award works. Total quality management. I spent probably a quarter of my career in total quality management. The shine is off that apple too, even though I think the like Six Sigma, if properly implemented, it's still the principles and promises are evergreen. That means last forever. So, and I'm gonna talk more about this in other video lectures. A constant emphasis on quality through the entire organization. Continual improvement, continual dedication to quality. Continuous quest to achieve improvements in product, service, equipment, people, procedures, blah, blah, blah. All members of the organization participate, and it only works especially if it's the key part of employee participation is the leadership. They're the only ones that can drive this. And that's where it fails. And that's where it becomes bureaucratic if they allow it to. And that's why the shine is off the apple a little bit. So, total quality management summarizes a management system for customer-focused organization that involves all employees in continual improvement. So here's the principles. I think there's only 5, but these work too. Customer-focused, total employee involvement, all work as a process. Integrated system means kind of the same thing. That would fit that under that. Strategic and systematic approach, which to me means senior leadership led. Continuous improvement, fact-based decision making, require people to use numbers wherever and however they can. Things that are measurable get improved and last longer if you can do that. And then communication. So we'll talk more about this as well. Six Sigma. So you have total quality management, design processes throughout the organization to have consistent quality all the time. So you want the aim of total quality is not to let defects get to customers. First of all, don't design defects, the possibility of defects into a design. If the process produces defects, don't let them get to the customer. So inspect them out. Inspection is expensive, so get to the point where you don't even need inspection anymore. And if you can do that, that means you're designing and producing good quality that doesn't require inspection so often. Six Sigma, the goal here is to ensure you're trying to get to, and when I talk about Sigma, I know you're all have taken 1490 stats, so plus or minus in a normal distribution, if you can get plus or minus 6 standard deviations of a process that has a bell-shaped or normal production curve, according to various measurable specifications. If you can do that, you're only going to produce 3.4 defects per million, which is incredible. When I first started with Ford Motor Company, we're measuring defects per 100. Defects per 100%. Defects. 2, 3, 4% defects. 2, 3, 4 of every car in almost every subsystem had a defect. So cars were having lots of defects that needed repair, and they were spending a lot of money on warranty. When they started getting the defects to 2, 3, 4, 5 per thousand, they've saved a lot of money. And 10,000, they can get to 3.4 defects per million vehicles. You're talking Toyota-like performance. And most of the car companies have gotten there. And here's a scientific method version that Six Sigma is built on. Define, measure, analyze, improve, control. DMAIC, which they pronounce DMAIC. So the summary in this part is processes are the activities that transforms inputs into outputs. Manufacturing processes produce tangible outputs that can be inventoried. Service operations provide a capacity to provide the service, but it's not inventoriable. Quality is an element to both manufacturing and process. We've spent some time on the idea of bill of materials. So the explosion of that bomb will tell you about independent and dependent demand. So we want to forecast the independent demand and then use the recipe, the bill of materials, to define the dependent demand for those products. Thank you very much. And next we'll be covering transportation overview.